Okay, this question is about quadratics. It's a very straightforward question if you know how quadratics work. So basically, just going to do a sketch to show you one or two things about quadratics. And I'm going to draw this quadratic. The quadratic's got a minimum at x equals -1/2. So over here, it's not quite a great drawing here, but yeah, but it's not actually going through there. It could be anywhere along this line. Now I know it doesn't go through there because we've got two zeros. Now I've got 1 0 that's over here. This isn't quite to scale, and 1 0 that's over here. That means where the graph goes through, it's a positive x squared, which means it comes down like this. So basically my actual zero answer, my minimum point where x equals -1/2 is there, and then it comes back up like that. Sorry, that's not a very good quadratic, sort of like that. Now the most important thing here is that this is -1/2. The distance this side and the distance this side, they're the same. Now, it may not look like it on my diagram. Like I said, it's not to scale, but those distances are the same. So if the distance between them is 11, then that distance is 11/2, or 5.5. So if this is a half, -1/2, then the distance from -1/2, so I do x equals -1/2, and I'm going to add on 5.5. So that's going to take me to 5. And then I've also start with -1/2, and I'm going to take away 5.5, and that gives me -6. So that's where the two zeros are. Once I've got those two zeros for A, what I'm going to do is factorize them. So it becomes x, now not +5, but x -5. So the zeros are just negated in a factorized form. And instead of -6, it becomes +6. And I expand this bracket to give me x squared plus 6 minus 5 plus 6x minus 5x is plus x minus 30. So my two values, q is 1 and r is -30. And it really all stems from that ability to understand that there is the minimum and it's symmetrical about the two zeros.